Okay, students, see the second question. So if you want to find out means, you know the value, delta G means, you know the formula, delta G is equal to del H minus T del S. So all the quantities are given, okay. So temperature, del S, del H, okay. So it should be joule, no. So we are converted into, you know, this also kilojoule, this also kilojoule. Now only we can able to substitute, okay. So this is, you know, minus minus 10 minus, you know, T is what? 300, okay. Delta S means, you know, into minus 20 into 10 power minus 3. So simple, okay. Then, you know, that minus, so automatically here it will be plus, okay. 300 into, you know, 20, we have 6000, okay, into 10 power minus 3, understood? You know that by 1000 it will be what? Minus 10 plus 6 only, understood? By 1000 means it will be 6 only. So here minus 10 plus 6, no. So answer will be what? You know that minus 4, understood? Simple one. So A is the option, understood? A is the correct answer. Are you following? Only one thing you have to remember, both in same quantity or not. One is kilojoule, one is joule, no. So it should be in same. That one you should see. Then you should remember the formula. If you know this, you can use to solve the sums, understood? Okay. Next one. Another one is, another model sums we have, you know, for the formation of ammonia, N2 plus H2 gives NH3, delta H naught, nothing but, I already told you, naught means standard enthalpy of reaction, okay, is minus 92.4 kilojoule per mole. What is the standard enthalpy of formation of NH3 gas? Okay, formation, see, just remember, formation of ammonia means, how ammonia is formed? Formation means, just remember, 1 mole only we want only 1 mole, not more than 1 mole. Formation, enthalpy of formation means 1 mole. Okay, 1 mole, how 1 mole of NH3 is formed? See, NH3, this is called 1 mole, no? Okay, how 1 mole is formed? What are the elements are needed to form this? You know that? N nitrogen is needed, no? Nitrogen means always we say what? N2. Hydrogen, it's a diatomic molecule, no? So we say what? H2. See, I want to prepare 1 mole of ammonia, okay, ammonia. So here N2 plus H2 gives NH3. So N2 means you put what? Here we have to balance the equation, no? Then only you should not touch any, you should not add anything, okay, you should not add any numbers in front of this. This is 1 mole of ammonia. For preparing 1 mole of ammonia, we put what? We should take what? Half mole of N2. Are you following? We want to get 1 mole of ammonia, we should take what? Half mole of N2 and what? Here 3 hydrogen is present, no? 3 hydrogen means we should put what? You know, 3 by 2. We just multiply 3 by 2 into 2, 2 to get cancel, we have 3 hydrogen, no? Okay. So half mole of nitrogen and 1.5 mole of hydrogen to get what? 1 mole of ammonia. Okay. So this is a way to find out, understood? So formation means we want to prepare only 1 mole of ammonia. Okay, that's a question. Okay. So what the symbol means here? You know that? What's the symbol? Enthalpy, standard enthalpy of formation. The symbol is what? Delta H. Standard means not. Delta H of formation, F is equal to, you know, question mark. Okay. Standard enthalpy of formation. Okay, this one we have to find out. Okay. But what they given? The given is what? Standard enthalpy of reaction. Reaction means here we don't have any fraction all will come. Here suppose, right, put the same equation here. See, N2 plus 3H2 gives what? 2NH3. That value is given. This is called nothing but standard enthalpy of, you know, reaction. R means, R stands for reaction, F stands for formation, understood? Okay, So this is given, this value is given, okay. So minus 92.4, minus 92.4, the value is given, okay. See, now we have to find out only 1 mole here. See, listen, 2 mole of ammonia is formed, this much energy is required. Therefore, 1 mole is formed how much? You just compare like that, okay. If you want to get 2 mole of ammonia, this much energy is needed, or this much of energy is evolved, okay. Whenever del H is negative means always it's exothermic reaction, you know that, okay. Understood? Are you following? Whenever del H is negative means what? It's called what? Negative means exothermic reaction. Whenever del H is positive means what? Positive means what? It is a endothermic reaction. Understood? It's a basic one, you must know, okay. See, you just compare. For 2 mole of ammonia, this much energy is needed. Therefore, for 1 mole of ammonia, they are asking only formation, okay, formation. So 1 mole of ammonia, how much energy is evolved means you just half of this, okay. You know what's half of this, okay. So half of this means what? You know, nearly 46.2 minus 46.2. Are you following this answer? Are you following? 2 mole of ammonia, this much energy is evolved. But formation means always 1 mole, just remember, okay, 1 mole, okay. So 1 mole of ammonia, how much energy is evolved? So half of this value is nothing but the B's option. Understood? Okay. Are you following? Simple one. Next question. See, 2 chlorine atom becomes chlorine. This is chlorine atom. 2 chlorine atom becomes chlorine molecule. Okay. That time, what is the del H value? What is the del S value for this reaction they are asking? Okay, understood. So you just remember, usually, del H and usually del H and del S. What is del H? What is del H? Del H means enthalpy of the reaction, you know. Okay, or heat changes at constant pressure is called what? Enthalpy, you know. Okay, enthalpy change means, suppose, during exothermic reaction, what? During exothermic reaction, this is what? This value is what? Negative. Okay. During endothermic reaction, its value is what? Positive. This only just remember. Okay. Understood? Then, see here, chlorine atom becomes chlorine molecule, no? Okay. So chlorine atom becomes molecule means one bond is formed. When bond is formed, then only it becomes molecule. Whenever the bond is formed means at the time, whenever the bond breaks, generally, whenever here is the, it's a bond between A and B. Okay. Whenever if you want to break the bond means we must give energy. Then only we can able to break the bond. If you give energy means what? That kind of reaction is called what? Endothermic reaction. So endothermic reactions, I already told you, del H is always what? Positive. Here, whenever atom becomes molecule, the bond is formed. During bond is formed, del H is value is what? Always negative. Okay. So del H is negative. Understood? Are you following? During bond formation, always del H is value is what? Always negative. Okay. Now come to del S. Del S nothing but entropy change. Entropy. What is entropy? Disorder of the, simply we can say disorder of the molecules. Whenever the molecule disorder, that suppose I am taking solid, liquid, gases, okay. Whenever the states comes from solid, liquid, gases, in solid state, the molecules are orderly arranged, that. Whenever the molecules are orderly arranged means entropy is 0. No disorder taking place here. When come to liquid state, there is some disorder. When come to gaseous state, it is more disorder. Wherever the more disorder taking place, that states only entropy will be very high. In gaseous state only, the entropy is more. Okay. Entropy nothing but disorder. Okay. Disorder is called, we can say, entropy. Understood? Okay. Here, no, in this case, number of, you see the left hand side, here 2 species are there. 2 species are there. No, 2. Right hand side, we have only 1 species. Whenever the number of species decreases, entropy is